Hello, welcome friends. So we want to find x in this question such that x is in real number. The solution. So let's write down our question. Of 14. So let's simplify by trying to make this written in this form. 3 to the power of 2, which is the same thing as 9, plus 3 to the power of 3, which is the same thing as 27, equal 14. And recall, if we have e to the power of n, e to the power of nm, like this, can be written as e to the power of m. So it's actually, you can write it as this, because this is actually commutative. So 3 to the power of x plus 3 to the power of x of all squared plus 3 to the power of x all cubed equal 14. So this is what we have. So if this is what we have, let 3 to the power of x equal m. So that we have m plus m squared plus m cubed equal 14. So that we can have m plus m squared plus m cubed minus 14 equals 0. And we can write it as m cubed plus m squared plus m minus 14 equals 0. So we want to look for the value of m. So but notice, let's try and so that we can know our factors, that we can actually representing represent all this in such a way that we can factor out what is common. So but notice that if we substitute 1 as our m, let's see if it will satisfy, so that we know, if we can know one value of m that will satisfy this, then it will be part of our factor and to be easier for us to factorize. So m as 1 cube plus 1 squared plus 1 minus 14, it won't give us 0. But if we try 2 cube is going to give us 8, plus 2 square is going to give us 4. So 4 plus 8 is going to be 12, plus 2, which is 14. 14 minus 4 is going to give us 0. So hence we know that m as 2 will satisfy. So m minus 2 should be in that factor. So how do we ensure we have m minus 2 in this factor? So let's try and manipulate this so that we can actually have that. So in doing that, you can see that m cubed minus 2m squared plus 3m squared. See, if we add up these, we have m squared. So we have not changed anything, and we can actually factor out from here m minus 2. We factor out what is called, which is m squared. We'll actually be left with this m minus 2. So that's why we are doing this manipulation here. Then after this, we can decide to say, okay, let's, for this, we can rewrite it as minus 6m plus 7m. So we have minus 14 equals 0. Minus 14 equals 0. Let me write this. So we have m cubed minus 2m squared plus 3m squared minus 6m plus 7m plus 7m minus 14 equals 0. So that's what we have. So if this is what we have, let's try and see how we can simplify this. So you can notice that m squared is common here, and we're left with m, because if we multiply this to get back to this, so minus, we'll be left with 2 plus, what is common between these both is 3m. Factor 3m, we are left with m minus 2, because 3m times m will get back to 3m squared, then 3m times minus 2 will go back to minus 6m, plus, what is common between these both is 7. We have m minus 2, so that if we multiply this, we get back to 7m minus, then we'll get back to 14 equals 0. So notice that m minus 2 is common between all these, so we'll factor n minus 2 all into, factor m minus 2, I left m squared plus 3m plus 7 equals 0. So we have m minus 2 equals 0, or m squared plus 3m plus 7 equals 0. So certainly we know that m is equal to, or now this m squared plus 3m plus 7 equals 0. Note that from here we can actually determine if this is going to give us real solution. So by using the discriminant, which is b squared minus 4ac. So if this is less than 0, then it's going to be complex root. Hence, it won't be part of our solution, because we are asked to find x in real number. So we are finding the real solution, which implies if it's a complex root, we will not be using this. But suppose we are asked that our x should include the complex root, hence we have to use that. So let's try if it's actually going to give us complex roots. Obviously it's that, but let's prove it and see. Our b squared is 3, so 3 squared is going to give us 3 squared is 9 minus 4 times our a is 1 times our c which is 7. Is it going to be greater or equal, greater or less than 0? So 9 minus 4 times 7, that's 7 minus 4 times 7, that's going to give us 28, and 9 minus 28 is going to give us minus 19. Hence is less than 0, which implies is a complex root. Hence we will not be needing this particular one. So that means we are only going to work with m equals to 2. So now, working with only m equals 2, recall that we made 3x squared. Sorry, we made 3 to the power of x equal m. So now we are going to have our 3 to the power of x, then we'll now substitute our m, which is 2. So now we'll be solving for x. So since we have our m, so we'll substitute it back to what we've let it before. So we have 3x, 2 to the power of x equal to 3 to the power of x equal to. So let's solve for x. So now, solving for x, we can apply log on both sides. Applying log on both sides. So applying log on both sides, if we have log of a to the power of b is the same thing as b log a. So we have this. So let's apply this here. So we are going to have x log 3 equal log 2. So dividing here by log 3, divide here by log 3. So log 3 divide log 3, and we're left with x equal log 2 divide log 3. But you know that if we have log a divide log a divide log b is the same thing as log A is B. So apply this here. So applying that here, we're going to have x as log 2 base 3. So let's substitute this value of x and see if it will satisfy our equation. So going back to our equation, we have it as 3 to the power of x plus 9 to the power of x plus 27 to the power of x equal 14. So substituting it here. So now let's try that by 3 to the power of our x is log 2 is 3 plus 9 to the power of log 2 is 3 plus 27 to the power of log 2 base 3. Is that going to be equal to 14? Let's find out. So now this, you can write this as this is the same thing as 3 to the power of 2 log 2 base 3 plus 3 to the power of 3 log 2 base 3. Is that going to be equal to 14? So simplifying this is going to be plus, you can bring this back here, that's going to be 2 to the power of 2 base 3 plus 3 log 2 to the power of 3 base 3. Is that going to give us this? But remember, if we have a to the power of log b base a is the same thing as b. A to the power of log b is the same thing as b. So apply that here. So 3 to the power of log 2 base 3 is going to be 2 plus 3 to the power of log 2 squared base 3 is going to be 2 squared plus 3 to the power of log 2 cube base 3 is going to be 2 cube. Z equal to 14. So now simplifying this is 2 plus 4 plus 8. Is that equal 14? So now 2 plus 4 is going to give us 6. 6 plus 8 is 14 and is equal to 14. So the left hand side equal the right hand side, which implies we are correct. Our x is truly equal to log 2 base 3. Thank you. Be sure you like and subscribe.